In our last video, we talked about identifying the vertex of different functions. So it's important to remember our vertex form. A times x minus h squared plus k. And our vertex is at h, k. Vertex form can also tell us where graphs move, where graphs can transform. Our parent function always starts at the origin at 0, 0. But our graph can move from there. It can move up, it can move down, it can move left or right, it can get thinner or wider. So let's look at our first transformation. If k is positive, so we're looking at our value at the end here. If k is positive, our graph will move up. So if I have an x squared plus 3, my graph normally is at 0, 0, but it moves up 3 spaces. On the other hand, if our graph is negative, such as x squared minus 2, our graph would move down. So again, not the origin, but down 2 spaces. If h is positive, so now we're looking at our h values. So k moves my graph up or down. H is what's going to move my graph left or right. Again, h. Think about it, your vertex values. So if h is positive, our graph moves left. If I have a plus 1 here, my graph will move at 0, 0, it'll move left 1. And if h is negative, if I have a minus 4, our graph will move right. So at 0, 0, you're going to move your graph right 4 spaces. We can also change the values at the beginning, our a values. Those aren't in our vertex, but they do impact the shape of our graph. So if a is a whole number, our graph will get thinner. So it'll still stay at 0, 0, but it'll become skinnier. If a is a fraction, our graph will get wider. And if a is negative, we should already know this. Our graph will open down. So as I'm looking at my function, a makes my graph thinner, wider, or it flips over. H moves my graph left or right. And k will move my graph up or down. Make sure you remember your rules from last class with your vertex. Take the opposite of the h, keep the k to find your vertex value. So let's look at some examples. In this first one, I see I have an h value and a k value. So my h value minus 3. Well, if I look back at my notes, if I have a minus or a negative, my graph will move right. So if I see a minus 3, my graph will be moving right 3 spaces. If I look at my k value and I have a positive, if my k value is positive, I move up. So in this case, my graph would also move up 2 spaces. Same idea for the next one. Inside parentheses, my h value is a positive. So in this case, I will be moving left 4 spaces. Since k is also a positive, I will be moving up 7 spaces. I like to do those two values first before I look at my a value. So if I look at the next one, negative 6. If h is negative, I move to the right 6. If k is negative, I move down 3. And now let's look at our a value. So a is a fraction. If a is a fraction, our graph gets wider. So in our example, 1/2, our graph got wider by 2. I have 1/2 here again. My graph is going to get wider by 2. However, if I look at the next one, I've got a whole number. Whole numbers make my graph thinner by 2. So let's finish this one up. My h value is negative, so I'm going to be moving to the right 1. My k value is positive, so I will be moving up 4. So that's just identifying, but now let's look at the graphs of our functions. So again, let's look back. Our original function is a U shape. It starts at 0, 0. How will our graph move? My h value is negative, so I'm going to be moving right 2. And my k value is positive, so I will be moving up 3. So again, we won't start at 0, 0. We're going to move right 2 and up 3. That is our new vertex. So our quadratic function will look like this. In the second one, my h value is positive 4, so I'm going to be moving left 4. My k value is negative 5, so I'm going to be moving down 5. And I also have an a value here. My a value is negative. If there's nothing there, it's a negative 1. So if our a value is negative, you should know this already, our graph flips over. Our graph will open down. Let's find our new vertex. Start at 0, 0. Go left 4 and down 5. And our graph will open down. And those are your transformations of quadratic functions when your function is written in vertex form.